Okay, upload. I'm gonna start. My name is Majd. I'm a student at the Faculty of Mechanical Engineering at the Technion, and I'm the head of the Formula project at the Technion. We basically build a Formula student race car, and they participate in competitions in around Europe. So the team started in 2012, and since then each year they built a car and they competed in competitions all around the world. The team started in the mechanical faculty, and then two years ago we started working on an electrical vehicle and combined autonomous. So it became a Technion project more than just a faculty project, and we basically go work with the rules of the former student Germany, which is the main competition. The rules give us the basic dimensions and more about the safety of how to build the car to be safe for a driver if it hits something or flip or like in case of emergency, and of course based on good engineering practices and what we learn in the classes. This is the structure of the team. We have a marketing and social media team and outside relations, and all the four topics which lead the team: aerodynamics, autonomous, mechanical, and electric. And each one has his own sub-teams. So basically the competitions are for students. Each year at all the competitions combined, there's around 600 universities who participate in the competitions. If you have a question or specific topic you want to ask me about, so stop me, because I don't know like what you want to know more about. So this is like a short video about the competition, so you'll understand what we do. This is a competition in Austria in the circuit of Formula 1. Most of the competitions are in the Formula 1 circuits. Before we go on the dynamic events on the car and orbit, we go throughout a couple of inspections, rain check, sound check, driver check all the suits and everything, and that he can get out of the car in less than 5 seconds. And then we go on the circuit. We have four dynamic events, which is acceleration. It's just a straight line. And there is a speed path, which is an 8-figure. And then autocross and endurance, which this is the speed path. Every dynamic event tests the car in her own parameters, because it's different to build a car just for acceleration and to build a car just for speed path. The hard thing is combining everything together and making a car that can compete in everything.
So who is driving the cars? You or professional drivers?
No, students from the team.
So it's also up to them. I mean, the better they are driving, right?
Sure. So the other two dynamic events are autocross and endurance. The autocross is just one lap of 1 kilometer, which is like the driver has to get out the most of the car in straight lines, slaloms, and curves. and the endurance is more to see how the car handles endurance. It's 22 kilometers. Basically, test all the calculations that we did for the chassis and also the power supply. ما زي سبيك يعني سبيك
power.
Just need to check that we have enough power and that we did the right calculations for how long the car should hold on the circuit.
So when you develop the car, do you have a track in mind that you're trying to, you take the decisions based on predicted performance? You do, what kind of decision-making process do you do?
Yeah, so we basically, I'm gonna get to it later.
Okay.
I'll explain more. So this is the inspections that we go through. We also have static events to explain, like, because we're students, it's not just to participate in a race, it's more about to show that we're engineers and we know what we're doing and we're building stuff based on knowledge and not just like random designs. So the engineering design, we stand next to the car and explain to the judges why we chose this part and not another part, or why this material and why not other one. The cost and manufacturing, we explain like throughout the whole process from its being material until it's the final part, the process and the like bill of materials and the processes. The business plan is for we like demonstrate, or the judges demonstrate investors, and we need to convince them to invest in us, in our idea or something that involves the project.
Yes, do you have any budget limit for to build a new car?
What?
Do you have any budget limit to build a new car? Limitation about the cost?
Sorry, I can't hear you.
Is there any limitation about the
No, there's no limit for the costs. But like there's limits in performance or dimensions just
So
from
for the
the...
cost, there's no limitation.
No. But they take cost into consideration in the cost event, but you can see that when you look at the cars like that there's a huge difference between teams.
Yeah, so the first competition is to raise funds in the industry. That's the big competition.
Yeah.
So this is our cars from the beginning of the project. The first car, which is in 2013, we won the best rookie car, which is the car that participates for the first time, the best car that participates for the first time. And we've won a couple of stuff, but it's hard to win the whole competition. Like we've won this one static event here or there, but not more than that. So the first four cars were built around the GSX engine, which is a combustion engine for Suzuki. And then we always put a concept or a goal for each year. And for the first four cars, they were to finish the whole dynamic events. And to be like to build a real car, and after that they wanted to build we will get back to that. So after that they wanted to build the more competing cars, and they started a 3-year plan, which is to lower weight and to maximize the performance. And in 18, they got to the lowest car worldwide with a weight of 139 with an engine that can produce 62 horsepower, which is a very good ratio. And then in 19, we've won first place in skid pad, the 8 figure. And the 2020 we didn't build it because of the corona, and then we moved to electric cars. This is a short video about the car that's actually outside on one of the circuits in Czech. This is an autocross. As you see, the road is narrower and it's marked by cones, so we can, they limit us, so we can get to higher speeds. So because the higher you go, the more risky it is. So our main competition is more about acceleration more than about top speed.
Good control.
Yeah, so and this is our the last 2 years we built the first electric car for our team, and this year we're working on the second electric car combined autonomous. That's it. So our process is later, like each year we start with figure out ideas or concepts for the next year, and we start with the goal of the year. If it's to build a reliable car or to build a car that is based on getting the lowest weight or each team has its own goals. And then after that we start with building work packages, and we start with reviews, which is system requirement reviews, and then preliminary reviews, and then critical review, critical design review, and after that we send everything to manufacturing, or we buy whatever needs to be bought. So the whole design process is 3 months. And then the build or manufacturing is 2 months, and then we have 2 months to test and refine the parts or the car. So for a question about how do we get the parameters, we try to build a MATLAB code that have the parameters of the car, which is like wheelbase, center of mass, center of pressure from the aerodynamic package, the wheels, the friction, all the engine parameters, and we try to build one of the circuits or the roads at one of the competition. This is specifically from 2017, I guess, from Germany. And then just test out which parameters work best together in suspension or wheelbase or engine, and also weight of the car, and check what's the best configuration. and after that we check if it's possible in the CAD, like in the model. If not, we go back and change stuff and like it's iterations. And after that, like we put these parameters in the work package and we give it to like students or whoever is going to build this specific plot. So this.
How long does it take from the moment you set up your goals until you have the car ready for competition?
So it's almost a year. Okay,
okay. That's quick.
Yeah, it's tight schedule. We work around the clock. This is our powertrain system, the electric one. This is for last year's car. It's 350 volt and 180 amperes. It weighs 60 kilograms and the energy capacity is 6 kilowatts per hour. We basically design all the outside structure of the accumulator and we buy the signals. This is for driverless. That's my topic, but we basically like have a LiDAR and cameras, and the perception team gets this information from the LiDAR and the cameras, and then they like process it and then send it to state estimation. State estimation try to figure out if it fits the information that they have from the IMU and the GPS, and then they process this information and send it to control and send it to the actuator. The control also works with, and the estimation works with the dynamic model to figure out the rules. So for the driverless, we have the same dynamic events for the with driver and without. But we know like the acceleration and the speed pad, like we know it before that we go on the circuit. But autocross and endurance, we need to figure out once we're on the track.
So you don't know what the track looks like before you're on it?
No. But we have like a range of stuff, like a turn between, for example, 9 meters to 15 meters.
Right.
Yeah. We know the width of the road, stuff like that.
So the competition is like you study the track by driving on it?
Yeah.
And that's part of the competition, or that's pre?
Yeah, it's part of the competition. That's why it also, they have like for the first round more points than the rest of the round, because like it's if like so you don't take your time on the first one and then go there so bit fast. They want you to compute also the information in a fast way. So for what you asked, most of the teams have monocle chassis, which is very expensive, but it has a lot of advantages. Like it's lightweight and the torsion in it, in comparison to the tube chassis that we have, is like multiplied by 4 or something like that.
Our time is done, but so we're breaking for, I don't know, another coffee, but if you're okay, people can ask you stuff, but our session is over, but
okay.
Yeah, I'm happy to listen some more.
Another question. It seems from the video that the top speed is quite low. So our question is, I saw a foil attached to the back of the car, and it seems that it's manufacturing more drag than it's supposed to create lift. Reverse the or down, it creates also drag. What is the balance you do?
Yeah, it's one of the stuff that we take into consideration when we build the car, and we put this information in the dynamic model to check the right like balance between both of them, because the aerodynamics package doesn't affect that much at low speeds. According to the dynamic model, we can get to 180 kilometers per hour, which is like at this speed, according to the CFD and like all the analysis that we do on the car based on the shape of the wings, the cars, like each year it's different, but let's say this year the wings produce around 1,000 newtons at 80 kilometer per hour.
Do you reach 80 kilometers an hour?
Yeah, we get around 100 or 180, 120, sorry.
And the drag?
Drag is mostly like a quarter of it, like around 250. But like it's if you look at it, like if you want to compete in just acceleration, then you're right. It's better to remove the rear wing. But if you look at it in you have like turns and slaloms or whatever, then you need the rear wing because you need more stabilization for the rear part of the car.
And you can change the wing angle or remove it and put it on different sections?
We can use a DRS, drag reduction system. If you follow Formula 1, you see it like always open close. On the straight, you can open it, so less drag, and on the turns you can close it, and you have more downforce, but also more drag.
I have a question, maybe two. So every time you just build one car, or you build two cars?
We build like a prototype.
You have the prototype, then only build one car?
Yeah, only one car.
So how do you deal with the old car if you have a new one?
Each year we need to change little stuff, and also you can say that you get to the top of your engineering. So each year we build and design something better than last year.
But how about the previous one? You disassemble it or you text
It depends on the team. Like we just keep the aerodynamics package and the chassis like together, and we just present it in a museum or gallery that we have. Other teams like take it apart. We mostly take parts from it, like stuff that is like expensive. So we pass it along to the next cars.
Cannibalize.
Yeah.
תודה רבה.
Thank you very much.